Welcome everyone to this week's Science News. Today we'll fly 13 billion years back in time, talk about dark stars, quantum payments, the efficiency of solar cells, rubber that counts, a biodiversity cycle, scientists who shoot lasers at lava, how to dissolve plastic, and of course, the telephone will ring. The James Webb Space Telescope continues to deliver. It has already enriched us with befuddling new data about dark matter in the early universe and spotted a geyser on one of Saturn's moons, but this one will blow your mind. This visualization is a combination of data from the Webb telescope and earlier data from the Hubble telescope. It's part of a project called the Cosmic Evolution Early Release Science Survey. In this movie, we fly further away from Earth at 200 million light years per second. With that, we also fly back in time, more than 30 billion years in total, and through approximately 5,000 galaxies. Each of these galaxies contains billions of stars. At the furthest point of the visualization lies Mase's galaxy, which formed an estimated 390 million years after the Big Bang. It's one of the oldest and farthest galaxies we've ever seen. But Mase's galaxy is just one of many young galaxies that Webb can see. Their formation holds important clues about the nature of dark matter. When they say that time heals all wounds, I think it's this data they're talking about. We have more news from the Webb telescope today because a group of astrophysicists claims they might have found evidence for dark stars. Our sun is about 4.6 billion years old, but compared to the age of the universe, which is about 13.7 billion years, our sun is fairly young. The first stars are believed to have formed already 100 million years or so after the Big Bang. But astrophysicists are still trying to sort out the details. In 2007, Kathy Freese and her collaborators suggested that if a particular type of dark matter, known as WIMPs, is present in the early universe, then completely different types of stars might have existed back then. Normal stars create radiation and heat by fusing light elements like hydrogen and helium. These dark stars are not dense enough to ignite nuclear fusion. However, the dark matter in them annihilates, and that creates radiation, which can also heat the normal matter. This works even though the dark matter fraction is small, usually below 0.1%. Since the density of those stars is so low, they are huge, with diameters about 10 times the distance from the Earth to the Sun, and they can grow to masses more than 1,000,000 times higher than that of our Sun, though they don't survive long, so they wouldn't be around anymore today. The name dark star is maybe somewhat misleading. It's not that they're dark, it's that dark matter is what fuels them. Indeed, these dark stars are extremely bright, but compared to other early stars, which have surface temperatures up to 50,000 Kelvin or so, dark stars are cold with just about 10,000 kelvins or so. This is astrophysics for you, where dark stars are bright and 1,000 degrees is cold. In the new paper now, a trio of American astrophysicists, including Kathy Freese, who proposed the dark stars, say that they found 3 objects in the Webb data that might be candidates for supermassive dark stars. So that's one for each author, which is really cute. They found them selecting candidates for their distance from Earth, measured by their redshift, their size, and brightness. If they're right, this finding would be strong support for this particular type of dark matter, though I have a feeling that other astrophysicists will find other explanations for these 3 objects. Hello? Hi, Elon. If the standard model is correct, then quarks and leptons become conscious no later than about 13.8 billion years from start. So if the standard model turns out to not be correct, we might all lose consciousness. That's okay, I'll give you an honorary physics degree anyway. Talk later. Researchers from the University of Vienna have demonstrated how quantum mechanics could make digital payments secure. In a normal digital payment, interactions between customers, merchants, and payment providers are protected by a randomly generated code that's used to scramble up the message. If you intercept the message, what you get is useless, unless you know the code. These codes can technically be broken, though, if you just have enough computing power and enough time and are an evil person like this guy in the stock video, no doubt. Quantum cryptography now relies on the idea that if you make a measurement on a quantum state, that'll generically irreversibly change the state. This means you can tell when someone has looked at your message. It's like a seal on an envelope, basically, just with quantum physics. Using quantum states to encrypt messages isn't a new idea, but there are some challenges to using it in real-world applications. One is that it requires maintaining quantum entanglement over long distances and to measure single photons, which the current internet infrastructure isn't up to. Another one is that while you can tell that someone intercepted a message if it's quantum encrypted, that doesn't stop people from intercepting it. Think of the sealed envelope. Of course you can read it if you don't care that the owner knows someone read it. In the new paper now, they proposed and experimentally demonstrated a more sophisticated protocol that can cope with a network of parties you don't necessarily trust. They consider a situation in which there is only one safe channel, which is that between the client and the bank. The client and the bank must exchange some initial information that links them together. If the client then wants to make a purchase, they send information to the vendor, who checks whether the client's information agrees with that from the bank. If it doesn't, the purchase doesn't take place. Unfortunately, while current digital payment methods take just a few seconds, the study's quantum method took a few tenths of minutes, as they write in the paper. They say that the time can probably be cut down with technological improvements. Then again, maybe waiting a few tenths of minutes before buying that thing I just clicked on wouldn't be such a bad idea. A group of scientists from Switzerland who broke a record for solar panel efficiency last year has finally explained how they did it. Most solar panels are currently silicon-based. Under laboratory conditions, they have an efficiency of up to 25% or so. The efficiency tells you how much of the sunlight energy is converted into electric energy. The 25% can be somewhat improved on, but even theoretically, the efficiency of this type of material maxes out at 29.4%. The solar panels used to power space technology, like the International Space Station, are made instead from gallium arsenide cells. Their production is much more expensive than that of the more common silicon-based solar cells, but they are more resistant to heat, radiation, and ultraviolet light. They too, however, max out at an efficiency of 29.1%. A way to get around this limit is to use a combination of perovskite crystals with silicon. Perovskite has been used for solar panels for some time. Unfortunately, the crystals are very brittle and break down within weeks or months. But they work well together with silicon because both absorb light at different wavelengths. So if you put them together, the total efficiency increases. These combined materials are called tandem solar cells. Combining perovskite with silicon also makes the material somewhat more stable, though the stability still isn't great. You can see in this chart that these tandem solar cells crossed the 30% efficiency threshold just last year. This achievement was made by a Swiss group and independently certified by an American institution, but they didn't explain how they did it. In their new paper that just appeared in Science, they now explain how they coated silicon solar cells with those perovskites. The silicon is usually etched so that it forms micrometer-sized pyramids because this increases the surface area that can absorb light. Previous attempts to cover these pyramids with perovskites, though, just filled in the gaps, creating a flat surface. The authors used an acid to help the perovskites bind to the silicon pyramids without flattening on top. That worked indeed and resulted in an efficiency of 31.25%. They say that this might become a simple way to upgrade silicon solar cells. This method doesn't do much to improve the stability of the perovskites, though. However, another paper in the same issue of Science showed that they could create a tandem solar cell that has fewer defects, hence improving the stability. It had an even higher efficiency of 32.5%. So the 30s are the new 20s, just a little more brittle. That makes perfect sense. You might think that rubber isn't the smartest material ever, but two researchers from the Netherlands have now taught rubber how to count. Their rubber counter is a type of mechanical metamaterial that is a material with specially designed structural properties. It has these vertical slices in it which bend if you push it. The thin rubber beams fold to the side, affecting the next beam after themselves, which will then do the same thing when the top is pushed again. See how with each press one more of the beams bends to the right? I find this super cute, though I'm not entirely sure what it might be good for. Put it in roads to check how many people jaywalk. Put it in desks so that you can track how often employees hit their heads against them. Countless possibilities. A group of geoscientists has put forward an explanation for why biodiversity on Earth follows a 36 million year cycle. If you look at the biodiversity of Earth over time, it seems to have a periodicity with a recurrence time of approximately 36 million years. Scientists have known this for a long time from studies of the fossil records. They've also known that the movements of tectonic plates follow a similar cycle, but how the two are linked has remained a mystery. According to the new paper now, the missing link is sea levels. By combining a whole lot of data, the scientists found that marine biodiversity in particular changes significantly with the movement of tectonic plates. They say that's driven by change in sea levels and the water circulation and seafloor expansion that goes along with it. This periodically created bigger, shallower seas that increased the amount of marine life, which also benefited life on land. I imagine that the geoscientists of the future look at fossil records and try to understand why in some regions of the world biodiversity has risen and fallen in 4-year cycles. Hello. Hi, Rishi. Yes, they found that climate change is correlated with a decrease in brain size. No, that doesn't mean that air conditioning makes you more intelligent. You're welcome. A group of scientists from the University of Queensland, Australia, has pioneered a new method to analyze lava that could help predict how volcano eruptions are going to develop. Our planet currently has about 1,500 active volcanoes. About 10% of Earth's population lives within 100 kilometers of one of them. The issue isn't just that they might get rolled over by lava, which luckily rarely happens, but that volcanoes spew out a lot of ash and gases which you don't want to breathe in. Figuring out when to evacuate can improve many people's lives. In the new study, they used a laser to blast away lava layer by layer and then analyze the evaporated rock by mass spectroscopy. They tried this on samples collected during a 2021 volcano eruption on La Palma, one of the Canary Islands. They found different layers, some of which flow faster, some of which slower, that gave them new insights about what was going on in the volcano. The nice thing about this method is that it can be done swiftly at location, so it can aid better understanding of an eruption which might still be going on. That, plus the laser show, will make an additional tourist attraction. Researchers from Colorado University Boulder have developed a new way to get rid of plastic waste by dissolving it. We live in a plastic world, and I'm not talking about the new Barbie movie. Plastics everywhere, in landfills, oceans, and forests. It's literally in the air and by all chances in your bloodstream, too. The problem with plastic is that it takes hundreds of years to biodegrade. So it first breaks down into increasingly smaller pieces, and those spread across the world and up the food chain. Now, plastic is made of fossil fuels, so we could just burn it, but that releases carbon dioxide. Recycling plastic is possible but difficult because there are many different types of plastics and other stuff gets into the mix too, so the quality of recycled plastic degrades quickly. The new study now looked at one of the most common types of plastics, PET, that's used, for example, for water bottles and similar stuff. These are normally advertised as 100% recyclable, but the recycled plastic is of lower quality than the original one and can't be used in the same way. They treated the plastic with some chemical agents and then used electrolysis to break down the PET into its building blocks, the monomers. These can then, at least in principle, be used to recreate the PET polymers in their original form without the degradation. They write in the paper that their results set the stage for the development of electricity-driven recycling methodologies. I quite like this idea, but I think in the end the key question will be how energy intensive this process is. I mean, if you wanted to, you could shoot at plastic waste with the Large Hadron Collider, decompose it into quarks and gluons, and call that recycling. But maybe I shouldn't give particle physicists marketing ideas. Thanks for watching. See you next week.